from, no, it's a bit like distance time graph, except it's displacement. So this one is like stationary, staying still. It is, this displacement is increasing at a constant rate, and this one, the rate of increase is increasing. Speed is distance over time. Velocity is displacement over time. Very similar. Okay, how do we do these?
So with our average velocity for each stage, so do I need to just first of all do do I need to change kilometers to meters?
Kilometers per hour. That's a good point. Well, this is kilometers.
Yeah, and then
this one's minutes. That's a bit different.
So for the first bit, 20 minutes, that's like 0.3 hours.
Yeah.
0.3, that's like a third hour speed. So am I doing, pardon, sorry?
Yeah, a third, yeah.
And so is that going to be like 20 divided by a third?
20 is a third for this one.
Sorry, 5 divided by a third.
Yep. And
so that'll be 15.
And that is 15 kilometers per hour. That's fine. What do you think? What would it be for B? Sorry, what would it be for second stage?
Would it be like 0 divided by whatever number, and it'll just be 0?
Yep. And is there anything you know about the third stage?
Will it just be 5 again for the distance?
Well, the time, it looks like it's different, but anything you know about what type of number you'll get?
A positive.
It was positive. It was 15 for the first part.
Oh, is it when you go down it goes negative?
So this will be negative.
Okay.
And that's because distance can be positive, but displacement can be negative.
Okay.
Let's see. How about part B?
I probably need to know like the velocities from. So I've got 15 to 0, and then do I need to do like -5 divided by?
Yeah.
5? Sorry.
You have the right idea. That would be for part C, average speed. Part B is average velocity, which is total displacement over total time. What's the total displacement for this?
10.
That's total distance, total displacement.
So 0.
Yes. And so it'll be 0 over whatever.
Okay.
And so that's going to be 0. So total displacement will be 0. So this one was 15. Then it's 0 in the middle, then -20. And so I think it'll be 15 plus 20 to give 45, whatever it would be. Okay, it's not too bad. No exam questions for displacement graphs. Velocity time graphs. So this one is a constant velocity of 0. So I suppose that's staying still. This one's a constant velocity, and then this one is an increasing velocity, and it's increasing at a constant rate. How do you find the area of a rectangle?
Base times height.
How do you find distance?
Velocity times time.
Yeah. Or speed times time or whatever. Displacement is speed, velocity times time. And so the area under the graph gives you the distance. In a velocity time graph, the area on the graph gives you displacement. Very similar.
Okay.
Okay, how about this? So you have to find displacement.
Yeah. So am I first of all going to do 6 times 8?
You could do it in two parts. Overall, what shape does it make?
Is that supposed to be sort of like a trapezium?
Yeah.
Or
And so area of trapezium?
half a plus b times height,
Yeah.
and so that would be um a half 8 times no a half 8 plus 8 times 6 for the first bit.
Not 8 plus 8. 8 plus for the whole shape.
Sorry, a half 8 plus 12
Yeah.
times 6. Yeah, and so that will be I got 62.
Well done. And so unit?
Kilometers.
Yes. And so big picture is that it does make on meters. I think it was meters, was it? Yeah, meters per second was the speed.
Oh, Jesus, sorry, yeah.
So big picture is that it's a distance. Let's see this one. The acceleration. Okay, so how would you do part A?
So is it supposed to be like? Is there like a formula or something I need to know? Or
For a displacement time graph, you got the velocity by finding the gradient. For a velocity time graph, to get acceleration?
do I need to find the gradient or something?
Gradient, yeah. It's basically the rate of change. And so you would find the gradient. So,
Sorry, is that like me doing like 8 minus 0 over 20 minus 0?
yep.
So is it just 8 over 20?
Yep. What is that? 0.4, and it's meters per second squared for
Yeah.
acceleration. So every second, the velocity increases by 0.4 meters per second. How would you do B?
So that would be just me doing something like what I just do again 75 minus 60 or something like, oh no, 75 minus 0 over 60 minus 0 or
Change in Y over change in X?
will it just be 0?
No. So from the last stage, it's there to there.
Oh, so that's will it be so are the coordinates 60 0 and 75 0?
68, I believe,
8, sorry, yeah.
and 75, 0.
And so that'll be 0 minus 8 over 75 over minus 60.
Yeah.
And so minus 8 over 15.
Well done. And let's see. What will be part C?
Am I just doing the area of a trapezium again?
Oh, you're onto something. Or are you? The displacement. Yeah, it would just be area of a trapezium. Go on, let's try it.
And so would that be like half times 75 plus 60?
Length of this side?
Yeah. Which will be, sorry, 40.
Yeah.
Times 8. Yeah.
That's it. Whatever that turns out to be.
That's right. 460.
460. And unit?
That'll be meters. Yeah.
Yeah. 460 meters. Great. 460. So minus 8 over 15 for that part. 0.4 for the first part. Great. Let's see. Okay, unless you have any questions. This one. We have to sketch our own thing. Particle moves along a straight line. So velocity time graph. So particle moves along a straight line. Particle accelerates uniformly from rest. So it starts from 0 to a velocity of 8. Accelerates uniformly, so that means straight line. Oh, in t seconds. So it takes t seconds to do that. The particle then travels at a constant velocity of 8 for 5t seconds. How would you draw that?
So that's going to be just a straight horizontal line.
Mm-hmm.
Yeah. And then it decelerates and uniform to rest in a further 40 seconds. So is it now just the line going down for 40 seconds?
Yeah, I just want to see though. So I said this part was for 5t seconds. So how could you describe? So what would be like this point where it ends, or this point here? In terms of t.
So part the particle acceleration first. So is it that from 16 meters per second it starts to go down for 5t seconds?
Let's see. Let's see. So, well, you know how here you're at t seconds,
Yeah.
and then it goes 5t more.
Yeah.
So what would be this one?
60.
So here is 6t, and so how about this one here at the end?
It's resting a further. So it's going down. Oh, is that just minus 5t?
No. The particle then decelerates uniformly to rest in a further 40 seconds. So from here to here is 40 seconds.
Yeah.
So, okay, hang on. Maybe I'll just go about a different way. So that's just 5t. And then here is 40 seconds. Okay. Part B.
So if we just do t plus 5t minus 40 equals to 0.
No. Well, this total displacement overall would be 0. Or sorry, the total It just returned to 0 velocity at the end.
Oh, are we gonna find the area of trapezium and make equals to 0?
Why do you keep making it equal to 0?
Because I thought it was because it's a displacement or something.
This is a velocity time graph, not displacement.
Oh, right.
So the total area is equal to the displacement. So let's see. Okay, so area.
So that would be half a plus b times height, which would just be a half, and then 5t plus 6t plus 4t times 8. Equals to 600.
Well done.
And then to put that into my calculator.
Yeah, go on, try it.
Ten.
I'll take your word for it. T equals 10. Yep, great. Okay, let me see this one. That looks alright. The distance trials, that's okay. Let me see, total time. Yeah. Let's try this one. I did part A already.
Okay. So the total time for which the particle is moving. So it's moving for 15 plus 5t seconds. Is that 15 plus 5t equals to? Sorry, would it be 10 times 15 plus 5t equals to 480?
It would be, it says a displacement from the starting point until when it comes to rest is 480.
Is it just? Oh, so is it just then 15 plus 5t equals to 480?
No, it is total area equals 480 because area is displacement.
And so it'll be half a plus b times height equals 480. And so in other words, that'll be half times 40 plus 15 plus 5t times 10 equals 480.
That's it.
And then just solve from there.
And
that will be nine.
And is that the total time?
Seconds, I hope so, yeah.
That's the value of t. What's the total time taken for the total journey?
Oh, right, so that'll be 15 plus 36 plus 9.
Yep.
And so that'll be 24. 60.
9 equals 60 seconds, so 1 minute. Great. What? And then my part C, so we don't have to do it all. Oh, well, maybe we should, but anyway. So we don't do the whole thing again. The distance traveled while it is moving with constant velocity. So what distance does it travel while it's moving with constant velocity?
Pardon, sorry?
What distance does this particle travel at constant velocity?
Four times the period of time when it's decelerating. Is that like 4 times minus 10?
No.
Oh no, is it 4 times t?
Oh yeah, 4t.
Yeah, 40. Also, just 36.
So that's 36. Distance. That's time.
And so is that 36 meters or something more?
No, so that's 36 seconds. So it traveled at a constant velocity for 36 seconds. How much distance did it cover?
360 meters.
Well done.
Cool.
60 meters, yeah. Okay, let me see. How would you do part B?
By doing the area of a trapezium is equals to 4.2.
And this is kilometers. This graph is meters.
So I need to do 12 divided by 1,000.
I would do the other way, 4.2 times 1,000.
Which is 42,000. No, 4,200, sorry.
Yeah, and then you would just go from there. I think you'd be fine for that one.
Yeah.
And they want the distance in there. It'd be the same thing, base times height. Okay, this one's a bit different. How do we do this one?
So am I now going to have to separate this shape out into 3 different areas because you can't do trapezium?
You could separate it into 2, but if you want, you can do it all 3 because 2 of the 3 would make a trapezium as well.
Oh, actually, could I just you? Oh, right. So is it for the first one I can't do it? For the second two I can do it.
Yeah.
So for the first one, would I just do something like, even for the second one, can I still sort of do area of a trapezium?
Yeah.
Yeah, I just need to do it sideways though.
Yeah.
So is that like me doing it half u plus 10 times 3?
Very good.
And then for the second two, I just do the same that I've done before, which is plus a half times 7 plus 9 times 10.
Fabulous. Yep.
And that's equals to 100.
Well done.
And so I just put into my calculator now.
Love it.
Yeah.
Great. Let's see if this works.
Ten over 3.
Love it. Okay, part B.
So if I'm saying that u is 10 over 3, is that where I need to do something like get the coordinates, which will be 0, 10 over 3, and 3, 10,
Mm-hmm.
and just do 10 minus 10 over 3 over 3 minus 0.
That's it. And
I got 20 over 9.
20 over 9 meters per second squared. 10 over 3, 20 over 9. Great. Fantastic. Those ones.
Tick, I think.
That's great. Okay, Suvat. Did you do Suvat?
We have done 2.
Good. Should be no problem to you. Big picture. 3 things you know, 1 thing you need. So what would it be for this one?
Okay, so U is 4, V is 7.5, T is 40,
And for part
and
A,
D is,
sorry?
and SPS. They want S, don't they?
Yeah, S is S. And which formula is that?
That would be. I could do. S equals half U plus V2.
Yes. And then you sub that in and get the answer?
Yeah.
You okay for that one?
Yeah, I think so.
VT. And how would you do part B?
Would it be easier to draw it out?
No. I see A. So we have UVT. We want A.
Oh, right. And so we can just do V equals U plus A2.
Yep. And then
And so that'll be 7.5 equals to 4 plus 4EA.
plus 40A. 7.5. Yep. And is it 3.5 over 40 or something? I think so.
I got 71 over 50.
Okay. Just want to check. Hang on. Acceleration. Just making sure that you and I haven't done this. Okay, so I'm just gonna do one of each, so long as we're around. Let me see. After reaching particle. Okay, part A. 3 things you know.
So so what's the postcode be? Is it now easy to draw it or probably not?
No, just three things you know.
So A is 1.5.
Is a trick.
Minus
Correct.
Yeah. Is it U is A and V is 2?
Yeah. V is 2. This
T is 2, yeah.
T is T. That one's okay. Which
Yeah.
one is that?
V equals U plus A2.
Yeah. And then the next one is the distance, which is S. S equal. Which formula? Which will that be?
For B,
Yeah.
that will be S equals UT plus half AT squared.
I suppose by then you'd know time, so it'd be fine.
Yeah.
You could also do V squared equals U squared plus 2AS, because that has U, A, V, and S. Because the three things we know are U, A, and V. I'll write that down for B. After reaching B, constant deceleration. The particles at C, velocity, distance. Fine. Let's see this one. Yep. Okay, three things you know for this.
Time is T is 30.
T is 30.
Is it like U is 0 and V is 45?
Well done. V is 45. So for part A, they want the acceleration. So A equals A. Let me just get this thing. There's one of these is important. I just need to find it. Let's see. U, A, V, T. That's the very first one. And then the distance. S, U, T, and V. U2. Fine. Those are alright. Yeah, the big picture for that one was checking that you'd know it's 0. A skier. What are the three things you know for this one?
So U is 16, T is 40, V is 0.
Well done. Important bit is V is 0. The rest you'll be fine. Making a command decision, you'll be fine. Particle moves in a straight line from A to B. A to B. This looks a bit weird. Okay, let's try this one.
So we've got acceleration, deceleration. Is now a good time to make to draw it or not?
Never draw.
Never draw. Fine.
3 things you know, 1 thing you need.
So U is 0, V is 5, T is 20.
Yep.
And we want the value of A, and we want A as A.
Or A is X. Let me see. So which one would we use? We'd use the first one, would we?
Yeah.
Yeah. That's a lot less weird than I thought. Okay, those ones.
We were a tick, I think.
So now they get better. We have to use all 5. Okay, how about this one?
So is A5 is it like U is 3, V is 18?
Yeah.
And S is S?
And so which formula is that?
We could do V equals U. Oh no, it'll be V squared equals to U squared plus 2AS.
Yep. And don't you worry. When it gets worth it, I'll do one of these. Let's see. This looks... I think this is the one I was thinking of. Yeah. Let's try part A.
So is it now? So T is no, it's U is 13, A is -4, S is 20, and T is 2.
Mm-hmm.
And so I can now do S equals to UT plus half AT squared.
Yeah. So let's try this one.
And so that'll be it's either 5/2 or 4. Oh, it says times anyway.
Yeah. And so 5, so t equals, say 2.5.
Yeah.
Or t equals 4. And then the value of t when the particle returns to O. How would you do that one?
When the particle returns to O, is that like acceleration is positive rather than negative?
3 things you know, 1 thing you need.
So T is T.
Mm-hmm.
S is 20.
S isn't 20, I don't think.
Is S minus 20?
When it returns to O.
Is S not minus 20?
No. What is S at O?
0.
Yes.
And so is A 0?
No. Constant.
And so A is minus 4.
Yeah.
And I'm assuming that. So is D going to be 13?
Yeah. So
And so is it just again S equals to UT plus half AT squared?
yeah, very similar.
And so that will be. I got 0 or 13 over 2.
Let's say 7.5. And so 5 over 2, 4 was part A. And then 13 over 2, 0. What's that about? Do I have a better diagram? So this is maybe a better diagram. So we had to say a point here. So this is O. I'll do it up here. So this is the start. This is the end. The particle goes. It has a positive initial speed, but it's decelerating, meaning every second its speed is having a negative added to it. So it's like it's slowing down, but it's also eventually it will become a negative speed. So it will start moving to the left. And so it goes all the way slow, 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 and then it reaches the end, and then it comes back the other way. And so they represented it as looping around like that, kind of like a quadratic where it goes up, stops for a second, comes back down. When at the point, well, let's say this was the point. They have A down here. I think our point was A, and we have to say at what time does it pass A. So on the way out, it passes it at 2.5 seconds, and on the way back, it passed it at 4 seconds after its initial start. So this must have been like 1.5 seconds from here to here. And then for the other one, the reason why S was 0 is because its displacement, not distance, but displacement from start to end is 0, because it's back to where it started.
Yeah.
Okay. So that's just making sense of that stuff. Grand. And this one, solving it, it was a quadratic, so you got 2 answers. So the linear ones, just putting them in the calculator, they're kind of not worth doing it. I just had to check the quadratic one. Let's see this. Cars traveling 3 consecutive points. Okay. All right. How do we do these?
Okay, so what we're doing, U is 14, V is 20, and I'm not sure if this is necessarily true, but is S going to be 400?
Let me see. So you that would be, so you said U is 14.
Yeah.
That's for at point B. So you have A, B, C. And so for the journey from B to C, U is 14. For the journey from, if we did 400 meters, then it would have to be the journey A to C.
Yep.
So what is S from B to C?
300.
Yeah.
Oh, right, yeah. Okay. And so now we just do A is A.
A is A. You would solve for A. And then part B wants the time from A to C. Let's see. So how? I think you'll be fine. From A to C, what things do you know about the journey from A to C?
Would it still be? Is it now S is 400?
Yes, correct. Anything else you know about the journey from A to C?
Will U be 0
I'm not sure. Does it say from rest?
with constant acceleration? No. Will that just be the same U and V?
Well, U equals 14 is from the journey B to C. The speed at B is 14.
So does that mean that V will be 14 here?
That would be the journey A to B.
Oh, so will the V be 20?
Yeah, V is 20. And the third thing that we would use is the A from the previous part.
Yep.
Because it's constant. A was 0.34. And you would find the T equals T. That's fine. That's all right. I'm happy. Unless you have any questions. Let's
No.
see. Constant deceleration. Okay. This looks weird.
So t is t.
Mm-hmm.
A is 2.5. Or actually, is t. No, I think it's t and t. And minus 2.5. Sorry.
Yeah.
Is u 15.
Mm-hmm.
Is s x.
T is t.
True. I can either use v or s.
All right, pick one.
I'm gonna say v.
Okay, what's v?
Can I use the deceleration and u to work out what v is?
You need to know some other stuff. I can tell you. It'd be better to go with s. At the origin, what is s?
0.
S is 0. And the thing that I could tell you is v is minus 15. If u is 15 and there was nothing stopping it, it's like if something's thrown up. If this leaves at 15, it arrives at minus 15.
Okay, thanks.
S is 0. So get the time between that.
We could do s is equals to ut plus half at squared.
Okay, try that one.
And my answers are 0 or 12.
And so that's, I was expecting one of them to be 0. Because that's the time when it left the origin. Okay, how about B?
And so do I now need to do like s is x and do t is 12?
You'll get 0. The displacement will be 0 when time is 12. This time we don't want displacement, we want distance. Any idea how you could do that?
Could I do that by velocity times time?
Yeah, try that.
Could I do minus? Oh, I can't do minus, but can I do 15 times 12?
Try that. I think it'll work.
I've got 180.
Hmm, 90. What went wrong here? 12 seconds. So this is what I was expecting. This is what I was expecting. Why did this method? So they did a fancy method. I liked your method. The total distance. If it's going 15, you see it's not going 15 because its velocity is changing.
Okay.
So we can't. The acceleration is constant, but the velocity is changing. Here's how I would do what I was thinking. So this is a representation of the journey. If you say so here it's like t equals 0. It returns t equals 12. But for both of them, s is 0. Displacement is 0. We have to get distance. What I was thinking is you could cut the journey in half and double your answer, because basically your displacement, you'd get the positive half and the negative half. That's why it ends up being 0 again.
Okay.
And so how could you do that?
We just half our answer.
Ah, that's cheating.
That's all right.
3 things you know.
So we know that S is S.
No. Well, yeah, you're right. S is S, yeah.
And also that T is 12.
Definitely no. From the journey from O to A.
Oh, was T gonna be 0?
No. Journey from O to A. From O back to O, time took 12 seconds. O to A.
6.
Yeah. T equals 6. A is minus 2.5. This girl, she's always calling me.
V is minus 15.
No. V is 0 at the end when it stops. And then you double your answer. All right. How was that for you, Andrey?
Cheers.
Any questions in general?
I don't think so.
All right. Well done, Andrey. You did great. I look forward to chatting again next time.
Thanks. See you on Friday.
All right. Take care. Goodbye.
Bye.
Bye.